Good morning, students. Yesterday we were solving the NCERT exercise and we have solved the question number 2.3, 2.5 and 2.6. Also we have discussed about the vernier calipers, its least count and its principle. And first of all, I want to say sorry for the low resolution of the last video. For today's video, it will be resolved. So see here, exercise of the chapter units and measurement for question number 2.7. Actually, the low resolution of the last video was because of we have added question clip also, and with the solution clips. So by this video I will only read the question from the book, and you can see the question from your book, or I will provide also the PDF file of the exercise of the book. So manage this time. I will not show the question on the screen. I will read the question here only, and you will see, you can listen or you can see the question in your book or PDF. I will provide that to you. So see the question 2.7. A student measures the thickness of a human hair by looking at it through a microscope of magnification 100. He makes 20 observations and finds that the average width of hair is in the field of view of microscope is 3.5 mm. What is the estimate on the thickness of hair? So you can see in the question it is about the microscope and its magnification. There is a microscope of magnification 100. Magnification means it enlarges the size of the image. Means suppose the object size is 1 centimeter, so it shows 100 centimeter in the image found by the microscope. So this is about the question, and he makes 20 observations and find the average width of the hair in the field of the view of the microscope is 3.5 mm. See the question here. Magnification of this microscope here is 100. 100 means it magnifies the size of the image 100 times bigger than the object size, and the magnified image is 3.5 mm here. Magnified image size of the hair, it is about the hair, human hair, is 3.5 mm. So you know that the magnification formula, magnification equals to image size upon object size. So you can use here, formula is magnification equals to size of image upon size of object, means actual size. So here given magnification equals to 100 and size of image is 3.5 mm divided by size of object. So from this relation you can get the value of size of object, means what is the actual size of the human hair. So size of object equals to, by cross multiplication, 3.5 mm divided by 100, and it is equals to 3.5 into 10 power minus 2 mm. Okay, so this is about the solution of the question number 3.7 here. So I am repeating again the low resolution of the last video because of adding different clips, means question clip plus solution clip. For this video I am ignoring this. I will read the question only, and you can see the question from your NCERT book or the PDF file. I will provide that to you. So next question, see the question number 2.9 here. 2.9, see in your book. Question is, the photograph of a house occupies an area of 1.75 centimeter square on a 35 slide. The slide is projected onto the screen, and the area of the house on the screen is 1.55 meter square. What is the linear magnification of the projector screen arrangement? See the question here. Also, this question is about the magnification produced by the projector. So the photograph of the house occupies an area of 1.75 centimeter square on a 35 slide. So it is 1.75. It is 1.75 centimeter square. This is the size of the object, means photograph size is 1.75 centimeter square. So size of object, you can see photograph means object, and it is 1.75 centimeter square, and by the projector it appears 1.55 meter square. So size of image is 1.55 meter square. So first of all, we have to convert these two values in the same system of unit. It is in centimeter square, it is in meter square. So let's convert 1.55 into 10 to the power, see this is meter square, we have to convert it into the centimeter square. So it is 10 power 4 centimeter square. So this is the size of image. Actually, this is the area of the image, and this is the area of the object here. So formula is aerial magnification produced by the projector is equal to, what is the magnification? Size of image upon size of the object. So size of image is 1.55 into 10 to the power 4 divided by size of the object is 1.75. So by this calculation, you will get the aerial magnification. But see in the question, it is about the linear magnification. Question is, what is the linear magnification of the projector screen arrangement? So if aerial magnification, suppose by calculation of this expression, you are getting x. I am leaving this calculation for you. You can solve, you can calculate it. So suppose the calculation gives you the value of this expression equals to x. So this is the aerial magnification, and for getting the linear magnification equals to under root x. Aerial magnification, if it is x, then linear magnification equals to square root of x. So by this calculation, you will get the answer of this question, answer of this problem. Now see the next question. Next question is 2.10. So in this question number 2.10, the state the senior book, state the number of significant figures in the following. In previous lectures, means I think one day before, we have discussed about the significant figure rules, and there are 6 questions here. We have to find the significant figures of the given measurements or given values. So first is 0.07 meter square it is. So 0.07 meter square, we have to find the significant figure. So you know that if the number is, we have discussed about the rules of getting the significant figures. So if the number is less than 1, then the zeros or 0 before a non-zero digit is not counted as significant figure. Means ये significant figure count नहीं होगा, and this is also not a significant figure. So only 7 is the 7th digit which has significant figures. So it has one significant figure only. See the rules which we have discussed I think before two lectures, not two, I think before one lecture. Yesterday, before yesterday, one day before, we have discussed about the rules for getting the significant figures. Now see the question number 2. 2.64 10 to the power 24 kg. So also we have discussed about this rule कि the given value is decimal number. So all the digits which are non-zero, all are significant figures. And 10 for 24 also it gives the value for conversion of one system of unit into another system of unit. So only 3 digits are there. Only these 3 digits are there for significant figures. So it has only 3 significant figures. Next, 3 is 0.2370. 0.2370. It is gram per centimeter cube. Gram per centimeter cube, mass upon volume, it means it is density. So see this question number 0.2370. So all these 4 digits are the significant figures because the number is less than 0 and there is no 0 before a non-zero digit and between decimal point. So all these 4s are significant figures. Go through the rules for getting the significant figures. You can solve this question very easily. Next is 6.320. 6.320. Also it has 4 significant figures. 4 digits are there. And also it is given in the rule कि in decimal number the 0 is also including in significant figures. So total 4 significant figures. Next is 6.032. 6.032 also has 4 significant figures. And the last is I'm writing here opposite. 6th is 0.000 and 6032 meters square. So see here, we have given the rule, we have discussed the rule that 0 or zeros between decimal point and a non-zero digit, all zeros are not counted as significant figures. So only here these 4s are significant figures. So this is about the question number 2.10. Go through the rules for getting the significant figures. And now next question is 2.11 and 2.12. See these two questions about the round off numbers. Question number 2.11. See in your book, the length, breadth and thickness of the rectangular sheet of metal are 4.234 meter, 1.005 meter and 2.01 centimeter respectively. Give the area and volume of the sheet to correct significant figures. To correct significant figures. See here. It is about the significant figures. So see here, the dimensions are given of the metal sheet. L, B, H are given. L, B and H all are given. And we have to find the area. Where is the question? Give the area and the volume. So you know that the area and volume formula of the suppose L, B, H all are given. It means it is for the cuboid, and for cuboid area and volume we have to find here. Area equals to, for area of the cuboid is 2 into LB plus BH plus HL. By using this formula you can give the area of the metal sheet, and for volume you can use L into B into H. For these two, you will calculate the area and volume of the question. And now it is the question to correct significant figures. To correct significant figures नहीं, इसे होना चाहिए to correct means it is about the round off number. Means when you will calculate the area and volume, it will give you the value, means answer in number of decimal points, means number of digits after decimal points. So try to get the answer in normal digits form. Normal digit form means standard decimal number, you can say. Standard decimal number में होता क्या है? The number is given in this form 25.5 या 123.3, means just only one digit after decimal. So this is the standard decimal number. So whatever you will get the solution, your calculation after area and volume, try to convert try to round off the answer up to the one digit after decimal number. Try to get the answer to after round off, it gives the only one digit after decimal point. So try for this question also here. I am repeating what we have to do. You have to do the calculation of area and volume for the given values of LBH, and round off the area and volume values up to the one digit after decimal point only. That will be answer. And similarly 2.12 is question. Also try for this question 2.12. Now see the question number. We have solved 2.13. You can check the question number 2.13. We have solved this question during the discussion about the percentage error. So now next question is 2.14. See in your book, a book with many printing errors contains 4 different formulae for the displacement y of the particle undergoing a certain periodic motion. See here, there are 4 relations. First is y equals to a sine 2 pi t by capital T. 2 pi t by capital T. Second is y equals to a sine vt. Y equals to a sine vt. Third is y equals to a by t sin t by a, sin t by a, small a it is. And fourth is y equals to a by root 2 a by square root 2 sin 2 pi t by capital T 2 pi t by capital T plus cos 2 pi t by capital T. Now see here, these four relations are there for the periodic motion. It is general equation for displacement of a of the periodic motion. You will see these expressions in the last of the chapter. In the last of this book, the chapter is periodic motion. So see here, y equals to a sin 2 pi t by capital T, y equals to a sin, the terms are given in the question ki y is the displacement, a is the maximum displacement of the particle, v is the speed of the particle, t, capital T is the time period, है ना? So for all these terms we have to see कि question is rule out the wrong formula on dimensional ground. We have to check the correctness of the dimensionally correctness of the relation. See here one by one. The first question, y equals to a sin 2 pi t by capital T, and if this relation is dimensionally correct, then on both sides all the terms should have the same dimensional formula. So left hand side, in the left hand side, y equals to, say y equals to this is displacement, so dimensional formula is L. For right hand side, you can mark here left hand side dimension. Left hand side is capital L and right hand side dimension A. What is A? A is the displacement, so also maximum displacement. This is amplitude, you can say this is amplitude and this is displacement at the time t, small t. So right hand side A, for A it is L, and you know that this is sine and this is argument of the sine. This portion is called argument of the sine. Argument means angle, you can say. This is angle, and you know that the angle is the dimensionless quantity. It has no dimension, so it should have no dimension. Also it appears because see this 2 pi, no dimension because this is time constant. T, time, means it has dimension capital T. Also denominator time, dimension capital T. So there is no dimension of the argument of this expression. I am writing here sin t by t, no dimension. So finally the left hand side dimension is capital L, right hand side dimension is also L, so the relation is dimensionally correct. See here, if the dimensionally correctness of the relation we have to check, then we have to find the left hand side dimension, right hand side dimension, and both are equal, then relation is correct. So left hand side L, right hand side is also L, means we are taking the dimension of A, that is L, and sine, this is argument, it should have no dimension, also it appears no dimension. So finally, and sine का कोई dimension है नहीं, it is the ratio, so trigonometrical ratio. So left hand side L, right hand side L, so it is correct. See the second part. Second part was y equals to a sin Vt. A sin Vt. So left hand side dimension is same. Left hand side dimension is L because this is displacement, and for right hand side A के लिए dimension बना L, and again sin. What is the dimension of V? LT minus 1, and dimension of T for time, so it is T. Finally it is L sin L. So it is appearing the argument dimension is L. Sin के अंदर जो एंगल, sin के साथ जो एंगल बनी होती है, it has showing the dimension of angle is L, which is wrong because dimension of angle is nothing. Angle is a dimensionless quantity, dimensionless variable. So it is wrong. This relation is wrong because it's showing the dimension of angle is L here. So it is wrong. Third is y equals to a by t. Y equals to a by t sin t by a. This is the question. Sin a by t, sin t by a. So again, left hand side dimension is L because of y displacement, and right hand side A means displacement, that is L, and T is the time, and here sin T for time, and A displacement. So see here, it is also showing that the argument dimension is TL minus 1. Argument dimension is TL minus 1. So this is also wrong because angle is dimensionless quantity. So this relation, third relation, is also false, wrong relation. Dimensionally it is wrong. Now last 4 is y equal a by root 2 sin 2 pi t by capital T, 2 pi t by capital T plus cos 2 pi t by capital T. So let's see. Dimension of left hand side. Dimension of left hand side is L because of y, and dimension of right hand side, A dimension, displacement dimension. This is amplitude. Amplitude dimension is L, and root 2 has no dimension. So sin 2 pi has no dimension. T by t. See again. Time by time. No dimension. Plus cos. Again t by t because 2 pi is the constant. Only we have to take the dimension of variables. So t by t. So here also t by t. So check here. It shows dimension of angles are dimensionless. There is no dimension of angles here. So finally left hand side dimension is L, right hand side dimension is only L. So this relation is dimensionally correct. So this is about the question number 2.14. We will solve some more question from this exercise, numerical portion only. So for today's lecture, these questions are sufficient. So thank you very much and God bless you. Complete your exercise. Try to complete your exercise in your favorite copy. Thank you.